Hello, my name is Jan Solberg and I am with the Department of Science Education at the University of Copenhagen. Today I'll be sharing with you some of my experience from more than 20 years working in STEM education. As such, I am not particularly focused on STEAM, but as you will hear when we go along today, most of the things that apply to STEM education are also relevant for STEAM education. So I want to thank you for allowing me to be part of this conference, and I hope that you will find that the things I say here will be relevant and something that you can use in your future endeavors in STEAM agendas. Before getting into too much of the details about STEAM education, I want to just quickly explain why STEAM is important. And it came out of the policies in the United States around the 50s, uh, basically as a call to make schools better at ensuring that the students who came out of the schools were equipped to handle the different kinds of requirements of the workplace, mainly within the science and technology. So STEAM came out of the STEM agenda, which was something that basically focused on workplace learning. Since then, it's become much more focused on making students able to adapt to the changing ways of the world as in general, and trying to create the different relevant competencies necessary for them to be able to navigate in a increasingly complex world where they have to deal with things that are very complex, globalization and things like that. So we want students now to have a lot of complex skills such as creativity, critical thinking, and collaboration. And these things are things that are not only relevant for one subject, but all subjects. So this is why I mentioned that STEAM or STEM are basically aiming towards the same kind of agenda. They want students to, across different disciplines, be able to handle complex situations of the real world in an ever-changing environment. Problem is STEAM and STEM remains a vague concept. It's very difficult to grasp what it actually means. And despite how much momentum STEM movement has had over the world in the latest years, and despite how many projects over the last 20, 30 years that have been awarded to STEM projects, there still remains no consensus about the meaning of the acronym, and it's something that's difficult for teachers to grasp because there are so many different understandings of the concept. A colleague and I did a review a couple of years ago where we looked at over a 10-year period of time how many STEM projects have been awarded in Denmark, and tried to look at what kind of descriptions these different projects had about what the students were supposed to learn as they were learning STEM, or as they were being subjected to STEM teaching. Now, the interesting thing was that there are so many different ambitions for the students, and just to give you a quick list of some of the different things that the students were expected to do, you can have a look here. You're not meant to read all of them, but it just gives you an idea of how many different things people associate with STEM. And as an issue for that, it also means that for teachers and for students, STEM is something very vague and very difficult to grasp. You may have noticed one of the final things on the list was 25th century skills. And this is something that is very strongly related to the same kind of agenda as STEM and STEAM, in the sense that 21st century skills was also an endeavor to try and describe what is necessary for people growing up in the 21st century, what kind of skills will be required of them as they try to navigate of globalization and all kinds of different difficulties and challenging global issues. So, looking at 21st century skills, there are a number of frameworks, international frameworks that have tried to describe what that means. And if you look at that, there is a commonality between all the big frameworks out there. And that is collaboration, communication, computer literacy, social skills, and citizenship. So these are things that you would also find on the list for STEM and STEAM. And including in some of it, the frameworks, you can also find creativity, critical thinking, problem solving, and developing different kind of projects, prototypes, and trying to create a specific product. Now, these different aspects of 21st century skill mesh very well with the agenda for STEAM and STEM, and it points towards the fact that there are skills involved here that are not specific to any of the different subjects. And as such, it can be difficult to find out how to actually encourage these and foster these skills to grow in students when you're teaching STEAM or STEM. So the big question is, how do you then teach STEAM if there's nothing that you can draw from the different subjects? In fact, it's a common conflict of people involved in in STEAM and STEM when they talk about it, how to address the fact that the subjects have specific areas of content, different subject matter that is irrelevant to the subjects, and it is a point and an important point in and of itself that students learn this content. So rather than trying to just collect all the different subject matter and put it into one big pile called STEAM, we need to rethink how we teach the different subjects because you cannot get the students to learn and to retain all the information that is pertained within the different subjects. The reproduction of the existing knowledge that we have within each subject is very, very difficult because there is always a growing amount of relevant information out there, and students will also find information much more readily thanks to newer technologies like ChatGPT and Google and things like that. So the idea behind knowledge content being very, very important is changing. And it's still important, but there are also other elements to it that require us to teach in a different way. And especially when we're thinking about teaching STEAM, which is an interdisciplinary way of teaching. As I mentioned, there can be many, many ways of dealing with STEAM, or in this case, STEM, because you have many different definitions of what STEAM or STEM entails. But this is one of the definitions that I find to be very useful. These are 5 instructional principles for teaching STEM that relate to STEM but could easily be applied to STEAM as well. Now, the points of these 5 instructional principles is that they guide us to look at what does it mean to teach these different ways in when it comes to STEAM or STEM. And the first one is to integrate the subject content. As I mentioned, you can't just add all the content together when you're teaching STEAM. You need to be selective and you need to find ways of integrating it so that the students aren't limited in drawing upon specific subject content. One way of doing this is by working more directly with problem-centered learning. So using problems as the vantage point for students to learn, and that means designing teaching sequences that try to get the students to solve problems and thereby drawing upon content from different subjects. In doing so, it's also very natural to ask the students to have more freedom to make choices for themselves and do inquiry on their own, and therefore also being structured in getting the students to actually discover many of the things that you might traditionally just teach the students. And then another aspect of this could be to design different solutions and being structured in your way of coming up with creative ways of solving problems, testing how these different designs might work, and iteratively becoming more and more aware of how to solve problems in general, and also design different prototypes in general. And finally, a big important principle, which is also mentioned in the 21st century skills, is being able to cooperate with other students and using teaching sequences where the students are doing group work and are needed to cooperate in order to solve the issues. And making it sure that the students actually have enough time to work together to find out each other's strengths and their own strengths and weaknesses, and using those in a constructive way. I'd like to give you an example now of how these different instructional principles can be applied and what happens when you do so. And the example comes from a project called the ISI 2015 project. And this was a project where the students were involved in science teaching that tried to integrate innovation. And the idea was that local companies would challenge the students to come up with creative solutions to real life problems that they were facing. And in the case you see here in the picture, there was a local health industry company who was interested in figuring out, is there any clever way of creating some sort of contraption that could help health workers transfer patients from a wheelchair into a bed without the health workers being subjected to a big strain on their back. So the students would try out different prototypes and come up with different solutions and go and talk to healthcare workers in the industry and trying to figure out what the problem was. So integrating a lot of these elements that I just mentioned into the teaching. And what happened was that not all the students were originally motivated for science, but as this open-ended challenge came along, and they were actually more and more interested in science and felt that they had a place in science as they became aware that they had the capability to do something together to create solutions that were actually of interest to real industrial partners. Now, in one school, there were a group of students who were really unmotivated for science teaching. They were not motivated at all. In fact, they were very troublesome, as indicated by this picture here. In fact, it was so difficult for the science teachers to do any kind of teaching, as they explained the students were absolutely off task. However, after 2 years of working in this method, the students realized that they were actually able to gain something from it and found it meaningful to be able to use science to come up with solutions. So they started to exhibit what I would call hidden learning. And this, I'll explain what I mean by this. What happened was basically they went from this situation where the students were unruly to a situation where when I interviewed the individual students, they knew exactly what they were doing, what their role was in this whole thing. So basically, they were on task, very disciplined, and very capable of explaining to me what was happening. However, when I talked to the teachers, they were unable to say anything about what had happened with the students and how they progressed in these 2 years. They were, however, able to say that they were much better at science than they were 2 years prior. So the idea was basically in within 2 years, using these kind of instructional principles, the students went from unruly to very, very on task. But the problem was that only the teachers saw it, and they were unable to provide feedback to the students about how much they developed because they were unable to explain this hidden learning, this learning that the students had gone through. They were not unable to put into words what they were because when they assessed the students in their traditional way of looking at whether or not they were good at science, they would say, yes, they're good at science, but they actually have not learned more science. So they're looking only at content. The students had not really developed in any way. And this was a big problem, that there was something going on that the teachers were not able to conceptualize and much less able to give feedback to the students on. As one teacher explained when I asked him about this, he said, "Why is it so difficult to work with complex skills? We're able to recognize mathematical skills, such as the ability to solve equations to build a bridge. That's a skill we can handle. But skills pertaining to being open to others' ideas, to develop them, transform them into something new, and to take charge, those skills, they are skills we are unable to assess. Why is that so difficult?" And what the teacher is pointing to here is basically that what we're talking about when we're talking about STEAM instruction is that STEAM instruction promotes complex skills in students, and this poses a challenge to traditional ways of assessing students. We are used to using assessment to test students' knowledge, but not the kind of skills that we're talking about when we're talking about STEAM or STEM. And this is the core of what I'm going to be addressing here, because we need to be able to assess what's going on in order to help students become better at being involved in STEAM or STEM education. So one of the things that is really important to know is what you do when you assess something. So there is a thing called the assessment triangle, which is basically a way of saying that there is an alignment between learning goals and teaching and assessment. And this is a necessary alignment in order to assure that you're not creating different difficulty for the students and that they're focused on the right things. For example, if the learning goals are collaboration, design, and communication, these kinds of complex skills that we're looking for, then teaching should be about creating group work, making them solve problems and give presentations, because that way we're sure that there's a link between what we're asking the students to learn and what they're actually doing in the teaching process. Similarly, the assessment then should be linked to what's going on in the teaching situation as opposed to something that goes on afterwards. So observations and dialogue with the students and testing the student solutions as you go along are ways of ensuring that there's this alignment. And in opposition to this, you can. So what happens when we normally test the students for conceptual knowledge is that there tends to be a gap between what's going on in the teaching situation and what's happening in the assessment situation, and this potentially means that the learning goals and the assessment are isolated from the teaching situation, and this could be an example when we talk about looking for specific subject knowledge and the students' understanding, because we tend to use tests and reports that are taken after the actual teaching situation. So in these situations, it's impossible to know what the students were thinking. It's impossible to make observations about what the students are actually doing, and that creates a problem for the assessment. And this is what the teachers were experiencing in the ISI 2015 project, because they were unable to use this approach that they normally would by testing them and asking the students to make reports to conceptualize some of the things that they were actually wanting the students to learn. And they had not yet realized that there was a change in what they were trying to assess from a more traditional conceptual knowledge of the subject matter to something more complex, something more transdisciplinary. So basically, the point is that when you're trying to assess complex skills, then you need a systematic assessment that is embedded in the teaching. You need to find ways of ensuring that you're actually teaching and assessing at the same time. And this becomes a very powerful driver for professional development, because once you become aware of what's actually going on in the classroom in a way where you're also able to provide information back to the students about it, it's a very powerful way of also developing your teaching. What this means is that teachers need to be able to assess complex skills by identifying and defining relevant learning goals, designing relevant teaching situations where they can collect valid data, and using this data to promote student learning. These three elements are important, and I'll go through and exemplify what I mean by these. So looking at the first step, identifying and defining relevant learning goals, what we've seen so far is that there can be a lot of different types of learning goals involved in STEAM or STEM, but some of those that are most prevalent throughout the different frameworks and throughout the different projects that have tried to encourage STEAM or STEM education involve things like collaboration. You need to figure out how collaboration or creativity fits in your teaching situation, and you need to figure out how to look for the signs that your students are at a level that you would expect in a given situation. Defining these and finding out how to break it down into something that's viewable in a teaching situation is the first step. So step number two has two parts. The first part is about creating a relevant teaching situation where the students are actually doing what you're asking them to learn in a way that also provides you with an opportunity to collect data. Now, this could be, for example, using practical assignments. By doing so, you're getting the students to actually build something or create something like an essay or whatever it may be, perhaps a website, things that will allow you to see where the students might be struggling in the process, and at the same time also be training them and being able to make sure that they have the skills required to solve the issue. Similarly, if you're looking to get the students to be able to collaborate more and you're focusing on this as your learning objective, you need to design situations where they have group assignments that will allow you to see and test them in how the different individual students are able to be part of this collaboration. So the second part of step two is actually collecting valid data as part of the teaching. And different ways you can do that is probably things you're doing already, but it's important to know and notice how it makes a big difference whether you're doing it as part of a collective and aligned idea of looking for specific learning goals and designing teaching situations, or whether you're just collecting data without necessarily thinking about how it relates to the overarching goals. So examples of how you collect data could be when you have a dialogue. You could have a more or less structured dialogue with your students. There are different methods that allow you to elicit responses from the student that make it very clear what they're doing and how they're thinking about the different actions that they're taking, and thinking about the kind of questions you want to pose to them, and then also recording mentally or otherwise what the students are saying, is a way of collecting data that you're probably used to doing in many situations, but maybe haven't thought of doing systematically in a way that would provide you with data that you can use not only to provide feedback for the students, but also to record what's going on in a more structured way. So another example that is quite relevant, as many people are designing computer-based and virtual realities where you can have your students interact in ways that they can't in the real world for all kinds of resource or safety reasons. The number of commercial computer-based solutions are out there now, and by using some of these, you can actually get the students to do things in the virtual environment while also following them, and the system will automatically collect data that the teacher then can use as a way of checking in on how the students are doing. And finally, just getting students to produce something provides you with some very valid data on what they're actually capable of. Student journals, for one, it can be a very important tool in gaining access to what the students thinking and how they're working together and individually. So the final step is using data to promote student learning. This is a really important step, and as much research has shown, there's one of the most powerful things you can do as a teacher to promote student learning is to provide them with quality feedback. And one way of doing that is giving them oral feedback on as they progress. And oral feedback can be a little bit random in many ways. So thinking about what you want to focus on and what kind of oral feedback you want to be giving your students can be a way of getting a higher quality of this, and in making sure that the oral feedback you focuses on the things that you're trying to get the students to learn is one way of making sure that that happens. And this goes also for written feedback, which is another traditional form of feedback that many teachers use, but thinking very carefully about what kind of feedback are you giving the students as you give them written feedback. For example, are you focusing on conceptual knowledge, or are you focusing on different aspects more related to complex skills? That makes a huge difference in what the students take from the feedback. Then another aspect of feedback that's become more important is by the way that the students give themselves feedback. So self-assessment and different methods of getting the students to relate to something by themselves, to look at how they might improve their own learning, is another approach to this, with a number of difficulties, but done right, it can be a very powerful tool as well. And finally, you have another thing that's been becoming more and more increasingly popular also with the support of technologies, is when the students give each other peer feedback. And using peer feedback is also something that can be done right if you think carefully about it, but it's something that requires a bit of a setup and some careful reflections on the teacher's part to work properly. But all of this is just to say that these are different ways that some teachers are doing anyway, but thinking about how to use it in a structured way with that it aligns with what the teaching situation and the learning goals is the key to success in this situation. So, as we've talked about, the students are learning skills that teachers are not used to assessing. And as I've shown you, there are a lot of steps involved in becoming good at assessing these skills and providing feedback to the students. So this basically means that teaching STEM or teaching STEAM calls for professional developments. These are new skills that the teachers are required to obtain, and without these skills, it becomes very frustrating for teachers to teach STEAM or STEM. And this is what a lot of research has shown, that in the initial rounds of trying to teach STEAM or STEM, there are a lot of difficulties that the teachers have to overcome. And they can do so by sticking to it, or by being provided with some good opportunities to learn how to deal with these issues by training and other ways. But it's really important to understand that what happens is that the teachers, as quoted here, have to be able to step out of the director role and allow the students to find their own way through the lesson, which may involve unexpected directions. And that means basically that a lot of uncertainty becomes part of the teaching once you start teaching STEAM or STEM. And this is something that a lot of teachers find really frustrating, and also prevents some teachers from becoming active in this type of teaching. So, one way of looking at it, and one way it's been described, is that teaching STEAM requires what you could call a growth mindset. If you want to be effective as a teacher in this kind of teaching environment, you have to be more a facilitator of learning, and that can be important to bear in mind when you're starting out of the process. It can take quite a long time to get used to this way of teaching. And what you need to do, if you look at what teachers who have become confident in this, they say they're able to do, is that you need to be able to be flexible, open to change, collaborative, problem solvers, and aware of the recent trends in teaching and learning. So this points, as you may have realized, to that some of the same qualities that we're actually asking the students to develop as part of a STEAM teaching. So thinking about this, what we're asking the teachers to do is basically become the same kind of learners that we are asking the students to be. And in that sense, we have to make sure that the teachers have the resources and support to develop professionally in a way that allow them to become role models for the students, so that the teachers, in their approach to teaching, do some of the same things and have the same dynamic approach to teaching as we expect the students to have to the subject and to the STEAM teaching that they're exposed to. And in that way, there's kind of a loop between the teachers being able to teach in a manner that represents and shows the students what it takes to work in this kind of dynamic environment. So, in conclusion, STEAM teaching is a critical component in securing young people the necessary skills for engaging in a dynamic and complex future. We need to attend to this. We need to be sure that the students are not equipped with outdated skills and knowledge. And to do so, we have to do something related to STEAM or similar approaches. And this requires also a new approach to teaching, which involves more freedom for the students, but also specific instructional approaches that are more aligned with the kind of goals that we're looking for, which means that we have to think about teaching STEAM as something that will challenge the way we assess the students, and we need this assessment to be more structured and more systematic in order to be able to provide students with feedback, and therefore it has to be embedded in the teaching situation. We cannot rely on standardized tests to provide students with the kind of feedback they need in order to acquire these skills and in order to foster them. We need the teachers to be in the front, to be able to word and to point to the different complex skills that are important to developing the students. And this requires professional development. So you cannot expect teachers to adopt this new approach to instruction just by themselves. We need to bring STEAM into practice, as teachers must be able to take on new roles, and they need to be able to develop this kind of growth mindset that can support a continual development of practice. In order to do so, we need to provide teachers with resources and inspirational materials in order to find out how to do these things. And we can point to specific things that the teachers need to be able to do in order to bring assessment into the teaching, and as such become able to start a process of continual development as they become better at looking at what's going on in teaching, designing teaching situations that allow the students to develop these complex skills, and provide feedback to the students with regards to how the students are doing. This creates a loop wherein continual investigation and collaborative work between teachers can drive professional development in a way that is necessary to get STEAM to be part of teaching practices. Thank you so much for your time and your attention. I hope you have discovered a few new things about STEAM education, and I wish you all the best of luck in your future endeavors trying to promote STEAM. So I'll leave you with a few resources that you can use for further study. I've selected a few articles and chapters that I think can be useful in the process in your future. I hope you find this useful, and I wish you all the best in your future endeavors.